Good day. We are presenting our human factor design assignment on the auditory environment in open offices. Our presentation examines how office noise affects cognitive performance and stress using sound pressure level data. The key question is not only whether an office is loud, but whether its acoustic environment supports the work being performed. Our group members are Tan Zehong, Li Chia-kai, Tae Ying Chong, and So Jingheng. Our presentation follows an engineering problem-solving sequence. First, we identify the main noise source. Second, we examine measured sound levels. And third, we discuss the effect on the workers. We then evaluate suitable engineering controls and finally propose an improved office layout. Therefore, the presentation is organized around this workplace problem and design response rather than discussing research paper individually. Open offices improve communications, flexible seatings, and floor space utilizations. However, the lack of walls and physical separations also allows speech, phone calls, equipment noises, and movement to spread across the office. The main human factor concerns is not hearing damage. Typical office noise is much lower than industrial hearing risk limits. Instead, workers may experience distractions, higher stress, reduced comfort, and lower control over their environments. Speech is particularly problematic because it carries informations. Printers, pantry activities, HVAC systems, and circulations also contribute to the overall auditory environments.
From a human factor design perspective, the workplace should be designed to fit the workers and also their tasks. The acoustic environment is part of the physical work environment and should therefore support the concentration, comfort, and also performance. Open office noise is especially relevant for activities such as reading, writing, calculation, checking, and also design review. It can also affect privacy and stress. The design objective is not to ask the employee to tolerate unnecessary noise. Instead, the office should be arranged so that collaborative activity and focused work receive suitable acoustic conditions. This diagram shows the pathway from the noise source to the final design response. Noise begins with sources such as speech, phone call, meeting, printer, pantry activities, and so on, and also the HVAC system. The sound then propagates through an open space and reach the workers get who may not be involved in the activity. The exposure can result in distraction, annoyances, stress, and also reduced comfort. Ergonomic control should interrupt this pathway by reducing the noise at the source, blocking its transmission, and also separating the noise-producing activities from the focused work. This chart compares the office sound level with the occupational hearing risk reference. The more quiet private office condition in Sandal was 36.3 decibel, while a typical private office is approximately 39 decibel. Typical open plan office are around 52 to 58 decibel, and the simulated open plan condition reached 59.1 decibel. This value remains well below 85 decibel occupational hearing risk reference. However, this does not mean that they are ergonomically harmless. Moderate office noise can still affect concentration, stress, and also comfort, particularly when it contains understandable speech.
Hi, my name is Deng Chong, and in this slide, I'll talk about why loudness alone is not enough. So, we know that sound level indicators such as dBA and LAEQ are useful for measuring acoustic exposure, but they do not fully describe the distraction. Two sounds at approximately the same level can produce different effects. Steady HVAC or fan noise has little information content and may be easier to ignore. Understandable speech contains meaning, so the brain may automatically process it even when the worker is trying to concentrate. Task type also matters, like reading, calculation, proofreading, and detailed design work are generally more sensitive to interruptions. Therefore, office assessment should consider speech clarity, privacy, and task requirement, not only just average sound level. Next, open office noise also competes with the worker's limited attention. Speech is especially relevant to tasks that use verbal working memory, including reading, writing, proofreading, and data checking. The worker may maintain the same output for a short period by applying additional mental effort. However, this can increase cognitive workload and reduce comfort in the long run. In the Sanders study, short-term proofreading performance was not significantly reduced in the open plan noise condition. This is important because it prevents us from overclaiming. The noise did not immediately lower the task score, but other measurements showed that the condition was still affecting the participants. Furthermore, Sender et al. Compared a 59.1 dBA simulated open plan office condition with a quieter 36.3 dBA condition. The open plan condition produced significantly higher heart rate and facet skin conductance, which indicate increased psychological arousal. Positive effect decreased while negative effect increased. The main interpretation is that the worker may still complete the assigned task but with more stress and less comfort. This creates a hidden workload cost that may not be visible from productivity figures alone. For this reason, office evaluation should combine sound measurements with worker feedback on concentration, privacy, annoyance, and also comfort.
The preferred approach is to fix the environment first. The engineering controls are the strongest because they modify the workplace itself. The examples include acoustic zoning, enclosed meeting rooms, phone booth, absorptive materials, partition, and isolating printers or shared equipment. The next one is administrative control, such as quiet hour and room booking rules can support the design, but it depends on the user compliance as well. The last one is personal control. These include headphones or temporary relocation. These are useful as secondary measure. However, they should not be the main solution because they place the responsibility on the worker instead of correcting the workplace design. Our proposed layout separates noisy shared activity from focus work. The entrance, main circulation road, collaboration zone, meeting rooms, phone booth, printer area, and pantry are positioned on the noisier side of the office. And then an acoustic buffer, which may include a storage, partition, or enclosed room, separate this activity from the focus workstation zone. And the focus desks are placed deeper inside the office, away from the circulation and shared equipment. So a quiet room is also located close to the focus zone for tasks that require higher concentration. So this is a conceptual layout rather than a construction drawing. So its main purpose is to demonstrate acoustic zoning. So in conclusion, open office noise is not merely a hearing damage problem because the measured levels are far below 85 decibel hearing risk reference. The main human factor design concern is that the moderate sound dominated by understandable speech can increase distraction, mental workload, stress, and also discomfort. The evidence also show that workers may maintain short-term performance while experiencing higher physiological and psychological strains. So therefore, focused work, collaboration, phone calls, circulation, and shared equipment should not be treated as one acoustic zone. The recommended solution is to design the acoustic environment according to the task through zoning, enclosed room, absorption, buffers, and also quiet workplace. That's all for our presentation. Thank you.